On this chapter, which is broadly called more calculus, you are going to increase dramatically your toolbox in what regards your ability to differentiate functions and particularly to integrate functions. This first lesson focuses only on differentiation, okay? Particularly differentiating the inverse 10 function. Good news, you only need to know this formula. MF19 won't give you that formula, will give you this one over here. Where is it? This one over here. The one that I have here is broader. It includes situations in which the coefficient of x is not 1, like this one. And my honest advice is that on your version of the MF19, the one that you always carry with you, just right here in front, this formula, okay, which is very similar to the one that you saw there, but now the coefficient is square over there, and on top you have the coefficient itself, and then you'll be fine. I'm just going to spend a bit to tell you how this formula comes to be. I don't want you just to use formulas for the sake of using them. I want you to understand that there's a method, there's a reason why they exist, and you can very easily get them. It uses a combination of different things, but anyway, this is it. If you start with this, the idea is to get dy by dx. But you don't know, obviously, how to do that to begin with. So what is the trick that is being used? Start with what you have, and then put this in terms of tan of y. So tan of y is going to be equal to kx. So this means what? This means that x can be written as tan of y over k. We can now do one thing. We can do dx by dy, not dy by dx, but dx by dy. And you already know that if you differentiate this, you will get the second square of y over k. So if dx by dy equals second square of y over k, then dy by dx is going to be k over the second square of y. Now let's look at something else. You know that if you have this, if you square both sides, then tan square of y is going to be equal to k square x square. On the other hand, there is this identity that you've learned before, that second square of y is 1 plus tan square of y. So if you combine these two, you will know that second square of y is going to be 1 plus this, which is k square plus x square. And now you combine these two results, and you'll know that dy by dx equals k over, not this, but 1 plus k square x square. This is where the formula comes from. But the only thing that you need to do at this point is to just pick up the formula and use it every time you are asked to differentiate the inverse function of tan. I included here, this is beyond the scope of the syllabus, something similar for the inverse sine function and the inverse cosine function. The formulas are simpler. This is more used in further maths, but I put it here anyway, just for you to have an idea that this method does not work only for the inverse tan. It also works for the inverse sine and the inverse cosine.